Welcome to the lecture on Introduction to Weldability of Metals. So, weldability is a very important aspect when we talk about welding metallurgy, because ultimately what we need to know that how good or how in a satisfactory way the material is to respond to welding, and you are going to have the properties, desired properties of the weld. So, basically that is a relative term. So, you can say that weldability of certain material is better, or maybe in certain conditions it may be good or so. So, in this lecture we are going to have the discussion about the weldability, introduction to weldability, and some introduction about how to measure the weldability, how to have the knowledge about the weldability tests. So, coming to the definition of weldability. Weldability is the capacity of a material to be welded under the fabrication conditions imposed into a specific suitably designed structure and to perform satisfactorily in the intended service. So, it means that you always have the aim that the material which is welded, it must be welded in such a manner that it should be performing satisfactorily for the intended service, for wherever you are thinking to use it. So, if you talk about the weldability term, so it will be encompassing these following things, like the metallurgical compatibility. So, metallurgical compatibility, if you talk, so metallurgical compatibility means you have the in welding you have the base metal and you have the filler. So, the metallurgical compatibility means what is the degree of dilution that is possible. So, it means that the base metal and weld metal can be combined within the degree of dilution. Encountered in a specific process. Means what happens that many a times you have the base metal and you are using the filler metal, and they may not be exactly having the same composition. So, in those cases there will be certain degree of dilution, and it should be you have the that within that there is a certain limit for a particular process, so that you are getting the desired properties of the weld. Then the second point is the mechanical soundness. So, that is when you are talking about the property of the welded joint. So, you always aspire to have the good soundness, mechanical soundness of the material, that is good mechanical properties without much of the defects which should impair the mechanical properties. So, that is your it should meet the soundness requirement. So, whatever the soundness requirement is there, that you should have some tensile strength and some ductility and some toughness or so. So, all these things should be met. Then third point is the serviceability. So, it means the material should be able to work under the different service conditions. So, the service conditions may be varying from you may use it at a high temperature, or you may use it even at a very low temperature. So, that is your this serviceability is there. So, then the structure may be subjected to impact load or maybe the under the fluctuating loads. So, whatever is the criteria for the material to be used, under those criteria the material must be able to be used under service. So, that is the serviceability. So, it will be encompassing these points. So, if you talk about so what we saw that this will be encompassing these 3 points, and if so what we see in a nutshell that when we talk about the adequate weldability of the material. So, if the material has adequate weldability, so it means it should have full strength and toughness. After welding. So, that is your your related to the soundness requirement. Then you have it should contribute to good weld quality even with high dilution. So, that is what the point related to the dilution that was there. So, even with the high dilution, basically you must have the good quality of weld that can you can get it. Then you have the unchanged corrosion resistance after welding. So, then another point is that should not be embrittled when stress relieving. So, all these these are the points which should be fulfilled for meeting that the material has adequate weldability. Now, coming to the alloying elements, if you look at the there are alloying elements which are used in the material, and alloying elements have a say on the weldability of the material. So, the alloying elements have their roles in different way, like they increase the hardenability. Many of the alloying elements which are used, they will be increasing the hardenability of the material. So, that can be expressed even in terms of carbon equivalent. So, that we will see. Then alloying elements also are forming the edge hardening precipitates, grain refinements, they reduce the segregation. They also control ductile to brittle transformation temperature, and they are forming the carbides. So, coming to the first point, that is your the effect of these alloying elements on the hardenability. So, the alloying elements may increase or decrease the hardenability. Of HAZ. So, basically you have different alloying elements, and some of the elements may increase the hardenability and some of them may decrease the hardenability. The alloy, if you talk about steels, then in steel we normally talk about the alloying elements like chromium, vanadium, nickel, molybdenum, manganese, and so. So, these alloying elements, if they can control the tendency of forming martensite, and so what is happening that according to that I mean in that perspective these cold cracking also may be occurring. So, for that a parameter is defined, and that is the carbon equivalent, and carbon equivalent is basically defined as So, it has been defined by the researchers that percentage carbon plus percentage manganese by 4 plus percentage nickel by 20 plus percentage chromium by 10 plus percentage copper by 40 minus percentage molybdenum by 50 minus percentage vanadium by 10. So, wherever you see you will have the positive terms, it means that indicates that it will increase the carbon equivalent, and whichever has the negative term like molybdenum and vanadium, they are we see that they are going to decrease the hardenability. I mean carbon equivalent, and carbon equivalent basically hardenability is very much dependent upon the carbon equivalent and or the carbon content, in fact contribution by carbon in fact. So, we can say that these alloying elements will be there. So, they will be affecting the hardenability of the HAZ. Then you have other points like many of the elements, they will be forming the edge hardening precipitates, as we have seen that when we do the edge hardening, when we solutionize and then we are holding for some time. So, we get the edge hardening precipitates formed, and that is because of the alloying elements which are there. Then many elements they provide the grain refinement. So, many elements are used to act as the grain refiner. So, they basically by some mechanism they are working as the nucleating elements and nucleation sites, and they provide the means to increase the fineness of the grain. So, mostly apart from certain elements, you have mostly the carbide forming elements also. So, you have aluminum, vanadium, titanium, zirconium, and also nitrogen. They act as grain refiners in low carbon steel and carbon steel. So, they are working as the grain refiners. Many a times these alloying elements will be reducing also the segregation. So, that is also one of the role of the alloying element is. Then controlling the ductile to brittle transition temperature. So, that is also because many a times we know that many metals or most of the metals that may be used either in a different temperature environment. Now, when we decrease the temperature, then at lower temperature even the ductile materials behave in a brittle manner. Now, for controlling that temperature, that also is controlled by the effect of some of the alloying elements. Then the alloying elements also are forming the substitutional alloys. Then you have they also form the interstitial alloys, because depending upon the size. So, if you are using the if you have the substitutional alloy formation, then that is using the solute solution hardening, and otherwise you have the interstitial alloys also and they will be increasing the hardness or the mechanical properties by the lattice distortion or so. So, that way you have the carbon and boron, suppose they are having a smaller in size. So, they will be used as the interstitial alloys, and they will be increasing the strength of the matrix by these by, as we know that when there will be transformation. So, because of the induced stresses, the matrix becomes stronger because of the formation of martensite or so. So, you have the chances of having strengthening because of these alloying elements. Then you have many alloying elements are used to which are the carbide formers. So, that way they increase the properties of the material, improve the properties of the material. And many a times the alloying elements will be providing the deoxidation of molten metal without the loss of primary alloying elements. So so they have basically the affinity for oxygen more than iron, and that is why the oxygen will be taken out, they will be absorbed by them, and they will be taken out of the steel. So they will be acting as deoxidizers also in low carbon and medium carbon steels. So these are normally the the role of the alloying elements, and then accordingly all these have its bearings on the weldability of the materials also. Now coming to so as we know that when we talk about the weldability, so we have to see that how a better way the material is going to behave under welding, how it is, how satisfactorily it is going to perform its job under certain specific conditions. Now coming to weldability, so basically you have to assess the weldability, and for that there is weldability test. So the weldability test, its purpose is to gather information about the behavior of material during welding for establishing correct welding conditions. So basically it will be talking about the correct welding conditions which should be there, because ultimately when we talk about the welded specimen, especially when you do the welding, then you are more concerned about the weld zone and the heat affected zone, and you see the changes more pronounced changes in those zones. So these zones are going to behave in a different way. They may subject to increased strength and reduced ductility, reduced toughness or so. So you need to basically see that under which conditions of welding how the properties is going to be affected. So basically it will be providing useful information about the appropriate process selection. So once you do these tests, then you can it can give you the information about what will be the most appropriate selection, then what should be the preheat requirement. You can do the test with different preheats, and then you can also go for the different processes under different heat input energy input conditions. Then you can also do for the different joint designs. So that way that you can see that which of the these how these affects the weldability of the material. So then if you talk about the weldability, so it can be done directly. So you can do the test directly and then check it and or otherwise you can also do indirectly by simulating. So normally the weldability tests are classified as the theoretical test, simulated test and actual welding tests. So these are the different categories under which this weldability is defined. So the test is theoretical test, simulated test and actual welding test. So if you talk about the theoretical welding test, so what is happening is in these cases as we see that we can have a number of notched bend specimen and they will be austenitized. So you austenitize them at about 1150 degree centigrade, and then you cool at the calculated rates to duplicate the expected HZ hardness. So, and then what you do is you try to do the bend test. So, you bend them through 10 to 20 degrees. So, specimen can be bent through 10 to 20 degree, and if if it is possible to bend them, then they are said to have a sufficient weldability for a particular application, or sufficiently ductile. Basically that is how you do. So, you have the theoretical you have theoretically that what should be cooling rates, and in that particular cooling rate how it should behave. So, you are doing that, and then for you are doing the test. So, based on that, and if you feel that it is bending, so you tell that it is sufficiently ductile. Similarly, you have the simulated test. So, what you do is, in this case you are heating and cooling the sample. So, in this case you are heating and cooling a small sample over a thermal cycle exactly like that found in a particular weld. So, in that case as you see a particular weld which is undergoing that thermal cycle. So, in that way only you are going to use them to give that thermal cycle to that particular sample, and then you check its properties. So, that way will be the simulated test. Now, actual welding tests. So, but what we mean to know more is about the actual welding test. So, actual welding test basically will be again of two type. One is the fabrication weldability, another is the service weldability. So, if you talk about the fabrication weldability, now in that case you have the hot crack test, and then you have the cold crack test, or hydrogen induced crack test, or root crack test. So, that is the that will be determining the the susceptibility of the welded joint to cracking. So, that is your fabrication weldability. So, that determines the susceptibility of welded joint to cracking. So, what we do in this case is that you have different tests. So, you have the joint, and that joint is subjected to different kind of test, and we see that how much susceptible it is to cracking. So, for that we are bending, or we have the different type of fixtures on which we are fixing the material, we are doing the welding, and then also we are subjecting it to either the twisting or bending or so, and then we are seeing its behavior. So, that is your fabrication weldability, and that in that category you have the hot crack test. So, as we know that hot crack test is basically done where the cracking is found to be because of the low temperature eutectics because of sulfur and phosphorus. So, that we have already discussed. So, in that category we come across the test like hot crack test. Then you have the root cracking tests are there, and then comes the hydrogen induced cracking test, or a cold cracking test. So, hydrogen induced cracking test. So, this is basically these are the tests which are determining the susceptibility of the welded joint to the cracking. It may be under in the hot condition, maybe root cracking test, or maybe in the cold cracking case, where as we know that because of that is also known as the hydrogen induced cracking or the delayed cracking. So, there also you have that is cold cracking test. Similarly, another kind of actual welding test will be the service weldability test. So, this test it will be measured basically to find out the mechanical properties of the materials, because ultimately when you are welding the material you have to use this for the as far as its mechanical properties are concerned. So, it must meet the the requirements satisfactorily. So, for that its properties should be optimum. It should have optimum amount of or minimum amount of the properties which is required for its use in the service. So, for that we do the different tests, and under that, as you know, we do the tests like you do the tensile, hardness and bend tests. So, we are doing the tensile tests. You can have different tensile tests. So, using the on UTM machines or so. So, on that you do the test and try to have the yield strength and the ultimate tensile strength of the material, to know that what is its influence on the yield strength of the material. Many a times the yield strength increases and it may decrease also, and what will be the effect on the ultimate tensile strength. Then this will also talk about so that tensile graph, that will also talk about the ductility values. So, those values you can get from these tensile test. Hardness, you can have the hardness at specified locations, and that will let you know the presence of undesirable phases at the hard spots or so. So, they will talk about these hardness or micro hardness at different locations. Then bend tests are also carried out, and it will talk about how much you can bend it without rupture. Then apart from that you will have the impact test. So, impact test basically is very important, because in case of welding it is very much expected that the toughness should not be affected. Mostly that is affected because of the grain coarsening or so. So, impact test is done, notch impact test is done to measure the toughness of the material. So, that impact test is very important. Then we many a times we do the fatigue test. Now, fatigue test also is important, because the material which is already under the fluctuating load conditions. Now, that for that the fatigue properties need to be ascertained. The fatigue limit must be must not be it should be affected much. So, you may go for the fatigue test, and apart from that you have also properties like corrosion test you do. Then you can go for the creep test. So, all these different tests are required to be done on the material, so that you can say that the weldability is not affected, or weldability is satisfactory of the material for a particular set of operating parameters or so. So, that is about this introduction to the weldability. Thank you very much.